Vijay Mazran. Today we want to present about the industrial robotic assignments, the part 3. First, I want to introduce about my group members. This is Ms. Moon Chia, Mr. Tai Ling Wei, and myself, Mr. Sin Chun Gi. And then these assignments actually is related to the BFB 3000, the 3D printer. Actually, our reports will based on this few of the factors and all the questions that stated in the assignments. For the first questions, we are going to separate into the two parts. For the first part, they will be listed on all the specifications of the BFB 3000 3D printer. And then the second part will how we're going to relate it to our industrial robotics theories, which is the manipulator kinematics. Next, after our research, we have concluded that in this table, this is the BFB 3000 specifications, and then we will highlight the few important things. This is the dimensions, the x-axis, y-axis, and also the z-axis. And then for this model, there are three categories. The difference is we're using the single printhead, the double printhead, and also triple printhead. And then this will be the dimensions that's listed in below, which is the x-axis and y-axis is the same for the three type of the printer. The only difference is the z-axis. This will be the difference. There's about 210 mm for the singles, and then followed by the 210 mm 7-inch, and also the 210 mm for the triple printhead. You can see that this is the x-axis. The x-axis, which is is the 275 mm. This one is 230, and also the triple one is 185. This is due to, if you want to use the one printhead only, the dimension will be larger for the x-axis. If you want the two printhead, that means there's maybe side by side, and then this will take some places for the printhead to move. And then the next will be the z-axis resolutions. This will be the same for among all three types of the printer. And then next we want to discuss is about the temperature. Actual temperature is very important for this printer. Actually, it goes to 280 degrees Celsius, which is 536 Fahrenheit. And actually, this is how we are going to melt the material, the PLA material, and how we're going to form the object that we have prepared for in the photo size. Okay, this will be the others will be the other specifications related to BFB 3D print, but is not very important in this printer. This is the second part. This second part we are going to relate to how it's going to relate to our manipulator kinematics, the theory. First, we transform the BFB 3000 printer into the manipulators. First, we can see that this is the link, this is the joint, and also the base. And we will note that this the motion for the links, which represented by the black color ones, the bidirectional arrow, and then this is the length of the movement of the joint. We denote that this into z-axis, x-axis, and also y-axis. Next, this is the first point that how we're going to say that is related to our manipulator kinematics. The first is there are three links, and we can see that the blinkings over this represented the first links, second links, and also third links. That how the print is moved. Next is there will be three joints in the 3D printers. This will be joint 1, joint 2, and also joint 3, which is same as the 3D printer. And next, this is how the motions for the joint motions. The black color ones is how it is going to move. For the z-axis, it move up and down. For the x-axis, they move over here. And then the y-axis will move over here. This is how it's going to let the printhead to move to print out the object. And then the fourth one is the orthogonal joint. This is the orthogonal for the 3D printers. is also using the one of the concepts is called the orthogonal joints, which is the how is going to will be the input, and then this will be the output, and then the joint motion. When we can see that this is the input length, this will be the output length, and also this is the joint, and then this is the motion of the joint. For the this is same for the 3 joints in the 3D printers. And also we have find out that the degree of freedoms for these printers will be 3. Actually, degree of freedom is related to how many joints in the printers. So this is our answer is 3 for this printer. Next, the question 2 will be introduced by my friends, Mr. Tan Ling Wing.
Okay, so let me continue for the question 2. Okay, according to the question 2, we need to design a manipulator system, perform same task with as my friend stated just now, the BHP 3000 3D printer. Okay, but our design is for a larger scale industrial robot. Okay, so we need to state the specification, the dimension, and our own design specification, and we need to present it in RoboSim. Okay, so this one is our new design. The name of this product is SNT 2012. Okay, as you can see, this one is for larger industrial robot, so the size will be bigger than the 3D printer my friend stated just now. Okay, so this one we use a RoboSim to present. This one is a picture. Okay, so then we can see through the RoboSim. This one is a coding. Okay, the one is initialization, and this one we just okay. So then we continue to next slide. Okay, this one is a command. As you can see, okay, we use only one base in our design, one base, 4 links, and 3 joints. Okay, this one is a coding, and this one is a motion. Okay, this one is a motion. Okay, so this one is a specification of our design SNT 2012. Because this one is for larger industrial robot, so the size of course will be bigger. Just now the BHP 3000 3D printer is 275 millimeter, but ours design is 1400 millimeter. The size will be bigger. Okay, for XY is the same, 1400 millimeter, and Z-axis is 1200 millimeter. Okay, then of course, so because our 3D printer is bigger, so we can produce a bigger product. So we can choose, okay, the Z-axis resolution we can choose 1.0 mm, 2.5, 5.0, 7.5, and the biggest one is 10 millimeter and equal to 1 centimeter. Okay, okay, then this one is our another special feature, the speed of the print extruder volume. We can adjust the speed. This one is a new design and new invention from, if compared with the BHP 3000. Okay, and of course the weight will be bigger. Okay, the overall dimension bigger also. Okay, and this one, the maximum operating temperature, because we need to melting the material faster, and because because the product we produce will be bigger, so we need to use a higher temperature to melting the material. Okay, so then firstly then I pass the presentation to my friend Miss Wen Chia.
Now I would like to talk about what we did to sustain the development in 3D printer. As you saw, our 3D printer is called SNT 2012. The first is this one is the overall of our product. we have the air filter, printer head, print head, and the internal battery. Okay, now let's discuss about the first one. We have installed the air filtration system. Why we need to do so? Because as you know, the material that we use is the PLA, polyethylene. It is a chemical substance with toxic gases. So once we melt the tube, the PLA tube, the toxic gases will be released. And when you closer to the machine, you will feel a very smelly and stink. So to avoid the environmental issues, we add and install the system. It's called air filtration system. Besides that, we also install a lead acid battery as a secondary battery. This one we can replace the fossil fuels. Why I say so? Because the electric source normally that we use is come from the fossil fuels. We burn the fossil fuels in case to use the battery, so we can reduce the emission of the carbon dioxide. It can resolve the environmental issues also. And our machine is require low power supply. It's only at 60 watt only. So we can use the rechargeable battery for our design, and the new renewable energy is that is suitable for the topic that is very hot now, means green technology. As you know, the battery is actually is made by the chemical. That's why from the chemical we produce it and generate it into the electrical energy. So it save a lot of energy. The third one is the 4-in-1 print head. We did this development due to the concept of the 2D printer. The 2D printer have the external print head in 4 colors, which is the primary color red, blue, and yellow, and we also add the black color. The PLA tube melts first, and then with a very high temperature, which is maybe close to 280 Celsius. And then after that, we cool into a suitable temperature is to -200 Celsius. This case we can reduce the waste, because that day I saw the Mr. Brandon, after he completed to produce the object, he have to cut the waste. In case we need to reduce the percentage of the waste, so we cool in a suitable temperature. In the portable, since as Mr. Tan Lin Wei mentions, this is a large scale of the machines, we adding 4 wheels in the bottom of the printer. If it is more easier to bring to anywhere and without apply the power supply, so we use the secondary battery to move it and operate at the same time and anywhere. So this is all our presentations and the conclusion.
To conclude, our products actually is quite a difference with the BFB 3000 3D printers. Our products mainly is for the friendly user, and for the users that can use it anywhere, anytime. Thank you. This is all our presentations.